Okay, let's unpack this. Imagine you live on an island, and your daily commute, your connection to, well, everything work, shops, friends, it all hinges on this one uh, unique piece of engineering, a floating bridge.
Right.
Now imagine that bridge has been a source of just constant frustration for years. You might think, oh, a ferry is just a ferry, a simple way across the river.
Seems simple enough.
But wait until we deep dive into this one.
Uh-huh.
We're taking a fascinating and, yeah, pretty complex look at a really critical piece of infrastructure over on the Isle of Wight, the Cowes Floating Bridge.
That's the one.
And this isn't just about convenience, is it? It's really about connecting communities, keeping local economies going, and sort of navigating these constant changes in technology and the environment.
Absolutely. And we've got this stack of documents here, official reports, really detailed assessments, consultation papers, all about what happens next for this, well, historic crossing.
Yeah, quite the pile. So our mission today really is to pull out the most important bits, the key insights from all this material. We want you to quickly get up to speed on something that, maybe surprisingly, might spark some real aha moments about infrastructure challenges pretty much everywhere.
Mm-hmm. What's it facing now, and what are the options? Some might surprise you.
Exactly. So let's start with the history, because it's kind of amazing.
It really is. What's fascinating here is how something so local can, reveal these universal lessons. This bridge, it's a chain ferry. It's been running since 1859.
1859, wow.
Yeah. It's genuinely one of the last of its kind.
Yeah.
Think about that. Over 160 years of service.
That's an incredible legacy. And it's not just some, quaint historical relic, right? It's actually vital.
Oh, absolutely vital.
If it wasn't there, how far would people have to drive?
It's the only direct crossing over the River Medina between Cowes and East Cowes. Without it, you're looking at a pretty significant 10-mile road trip all the way around via Newport.
10 miles. Okay, so for daily commutes or, I don't know, emergency services.
It's a massive disruption, not just inconvenient. It's a lifeline for the area.
Right. Well, that brings us neatly to the current challenge. Floating Bridge 6, FB6. In service since, 2017?
That's right, 2017.
And when it first launched, it was, shall we say, famously unreliable.
That's putting it mildly, yes.
The sources here, they highlight some pretty major mechanical problems, everything from hydraulics, guide wheels, even the IT system.
It was a whole raft of issues.
And it led to suspensions peaking dramatically in 2021. The figure here is 212 full days out of service.
212, yeah.
That's almost 2/3 of the year. Just imagine the daily grind for people relying on it. Chaos.
Absolute chaos. It was a very difficult period for the whole community, no question.
But, okay, here's where it gets interesting, according to these reports.
Yes, because the Isle of Wight Council and their team, they've actually resolved these core mechanical problems.
Really? So they fixed them?
They did. It took a dedicated effort, replacing the hydraulic system, redesigning parts, new filtration, all 24 guide wheels replaced with steel ones, reconfiguring the IT, the works.
So a proper engineering fix, not just patching things up.
Exactly. And the result is FB6 is now much more reliable. Far fewer lost crossings, and passenger numbers, both cars and foot passengers, are back up, highest they've been since before COVID.
That's actually a huge turnaround.
It really is a genuine turnaround story for its operational reliability.
So despite those really rough early years, it sounds like the council properly tackled it. What do you think drove that, beyond just, throwing money at it?
I think it really shows the value of persistent engineering. Proper diagnostics. They didn't just patch. They found the root causes and fundamentally addressed them. Redesigned things, replaced things.
Deep technical understanding, basically.
Yes, and a commitment to solving it, not just papering over cracks.
Okay, that's genuinely good news. But there's always a but, isn't there?
There often is with complex infrastructure.
Even with those fixes, one stubborn, really expensive problem remained. Chain clearance.
That's the one, yes. Despite all the mechanical improvements, FB6 still struggles to keep the chains deep enough during strong ebb tides.
Explain ebb tides quickly.
Sure. That's when the tide's going out, so the river current is pulling really strongly towards the sea. Powerful forces involved.
Got it. And the Harbor Commission says the chains need to be how deep?
They mandate a depth of tide height plus 1.5 meters. That's for navigational safety, so other boats don't snag the chains.
Okay, and why can't FB6 manage that?
The fundamental issue, it seems, is weight. FB6 is about 100 tons heavier than the previous one, FB5.
100 tons heavier.
Yes, but the chains weren't upgraded to match. So when that strong ebb tide hits, the extra weight isn't enough to keep the lighter chains sunk down properly. They lift up.
Right. And the solution for this isn't exactly high-tech, is it?
No. To solve this, they use what's called a push boat, literally a small boat that pushes against the ferry to provide counterforce and keep the chains down.
A push boat. How much is this constant sort of Band-Aid costing?
It's a significant ongoing operational expense. The current contract for that push boat is costing the council around £90,000 per year.
£90,000 a year, just for the boat.
Just for the boat. Think about that over, say, a decade. That's nearly £1 million just to keep the chains submerged.
Wow. That really highlights something, doesn't it? How seemingly small design issues can balloon into massive recurring costs.
Absolutely. It's a powerful lesson in, whole life costing and long-term financial planning for these big projects.
Definitely. It just begs the question, how sustainable is that? Spending so much just to keep chains down.
Exactly. And it's not just the chains causing issues or, well, perceptions of issues. People also feel the ferry is just slower now.
Right. The documents mention it averages about 3.15 trips an hour, compared to FB5 doing 4 or 5. But you're saying the actual speed of the vessel is the same.
That's what the analysis suggests, yes. The vessel speed itself hasn't changed.
So what's really going on there? Why does it feel slower?
It's a great question, and the answer is, well, it's complicated. Several things contribute. Some are specific to FB6.
Okay.
Like its increased capacity, it carries 20 cars, whereas FB5 only took 12 to 15. So naturally, loading and unloading takes longer.
Okay, that makes sense. More cars, more time.
And there's also an 8-second hydraulic braking delay at the end of each crossing. That adds up.
8 seconds every time.
Okay. And this is crucial when we think about the bigger picture. Many factors are external. They would have affected FB5 too if they'd been in place then.
Ah, okay. Like what kind of external factors?
Well, for safety, they introduced segregated loading and unloading back in 2015. That was after an MCA inspection.
Before FB6 even arrived.
Exactly. And there's a mandatory 10-second warning beacon before it crosses. That's a Harbour Commission rule since 2013. Plus, it has to give way to other river traffic, also since 2013.
So all these little things add up to longer overall journey times.
Precisely. Even if the ferry itself isn't actually moving slower across the water, it's a good example of how a system's efficiency isn't just the machine, it's the whole operational environment, the regulations.
The whole dance it has to do.
Right.
And financially, looking at the bottom line for FB6, it's pretty stark.
Yeah.
It really highlights why they need new solutions.
It does. The total direct operating costs are around $1.7 million a year, roughly.
Wow. And the income?
Income is about £793,000. So the council is subsidizing the operation by about £900,000 per year.
$900,000. And that push boat cost we mentioned.
And £90 is a key chunk of that ongoing subsidy.
Yeah. Okay. So given these persistent issues, the costs, it seems pretty clear why intervention is needed. This isn't just about today's problems. It's looking ahead, right?
Exactly. It's absolutely crucial for the future. You look at the projections for cows and East Cow's population, households, employment. It's all expected to grow over the next few decades.
Growth means more demand.
Definitely. Vehicular demand for that crossing is forecast to increase by nearly 15% by 2040.
15%. If the crossing is unreliable or can't handle the capacity,
it just pushes more traffic onto that alternative 10-mile route via Newport, causing more congestion there. And it could seriously limit local economic growth, the vitality of the towns.
So that chain clearance issue, the push boat cost, it's just not sustainable long-term, especially for a growing community.
Not really, no. Something has to change.
So what steps have they taken? How do you even begin to solve something like this? Do they just, pick an idea?
No, not at all. The council didn't just guess. They brought in the experts, marine engineers, legal people, financial analysts, and they meticulously followed the Department for Transport's guidance for assessing options.
A proper process, then.
A very thorough process.
Right.
Their starting point, the baseline for comparison, is what they call the due minimum option.
Which is?
Just keep FB6 running as it is now, including the push boat and its costs.
Okay, so that's the benchmark. Then what?
Then they generated a long list of potential solutions, brainstorming everything, replacing the vessel, obviously, but also fix bridges, tunnels, even considered removing the crossing altogether.
Wow, they really cast the net wide.
They had to consider all possibilities initially.
And the first filter they applied was cost, affordability. which makes sense.
Exactly. Public money involved. So options with estimated capital costs over £25 million were immediately taken off the table.
25 million cutoff. So what did that rule out?
Well, that ruled out a fixed road bridge estimates were £50 to £100 million. And definitely ruled out a tunnel, which was estimated at over £100 million.
Okay, so no grand tunnel under the Medina, no multi-billion-pound engineering marvel this time around.
No. Sometimes the most practical solution isn't the harshest,
Very true. A sensible way to manage public funds. So what happened to the options that did make it past that first cost hurdle, the ones under 25 million pounds?
Right. Those remaining options went through a much more detailed assessment. They used this thing called the EAST tool, the Department for Transport's early assessment and sifting tool.
EAST tool. Okay. What does that do?
It basically gives each option a rigorous report card, evaluates them against criteria like strategic fit, economic value, financial viability, commercial aspects, manageability, the whole lot.
A proper deep dive into each remaining possibility.
Exactly. Very systematic.
So after all that sifting and scoring, what actually made the recommended shortlist? What are the real contenders now for the Cowes Floating Bridge?
Well, alongside that due minimum baseline, just carrying on as his two main do something options came out on top.
Okay, what's the first one?
Option 1 is replacement with a new vessel, call it FB7.
A brand new floating bridge.
Yep, completely new, designed specifically to fix the current problems. Things like having additional thrusters built in, maybe a reduced drag profile in the water.
And the cost for a new one? And how long would it take?
The estimate is between £5 million and £10 million for the capital cost. And the timeline would be something like 2 to 5 years to design, build, and commission it.
Okay. And they're pretty confident a new purpose-built one would actually solve the problems.
The confidence level is stated as high, yes. Design it right from the start.
That sounds like maybe the most straightforward approach. Build a new one, get it right this time. But there's another option, which sounds maybe a bit more intricate.
There is, and interestingly, this other option actually scored highest overall in the assessment, particularly in terms of offering the best value for money for taxpayers.
Better value than a new bridge. Okay, tell us about that.
It's called the phased package option, modify existing vessel and/or operational environment.
Right, so working with what they've got or tweaking the surroundings.
Exactly. It involves combining or maybe phasing in several different solutions. One key element is adding flush thrusters to the existing FB6.
Flush thrusters. What are those?
Think of them like small, powerful water jets built into the hull, flush with the side of the ferry. They can push the ferry sideways.
Ah, so they could directly counteract those tidal forces.
Precisely. Provide that lateral force needed to overcome the tide, which would mean...
No more push boat.
Exactly. Making the push boat redundant. That was actually the highest scoring individual intervention they looked at.
Interesting. What else is in this phased package?
It also considers adding additional control chains. These would help pull the vessel upriver against the current, especially at lower tides, and also something called tidal flow reduction.
Tidal flow reduction. How do you reduce the tide?
Well, you can't stop the tide, but it would involve targeted dredging of the riverbed around the ferry's path. Deeper water generally means slower flow velocity near the bed.
Ah, changing the river dynamics locally. Clever. Yeah. Okay. And the cost for this whole package, it sounds like it could vary depending on what they actually do.
That's a key part of its appeal. The estimated capital cost is significantly cheaper than a new vessel, somewhere between £1 million and £5 million.
1 to 5 million versus 5 to 10 for a new one. That's quite a difference.
Big difference. And the implementation timeline is shorter too, estimated at 1 to 2 years.
Faster and cheaper. But what's really fascinating, you said, is the strategy here. The phasing.
Yes. It's not necessarily about doing everything at once. It's a pragmatic, potentially iterative approach.
So, smart steps, not one giant leap. How would that work?
The idea outline is you could potentially try the cheapest solution first, maybe those additional control chains, see if that's enough on its own.
Okay. Trial it.
If it's not quite sufficient, then maybe you move to the next step.
Sure.
Do the detailed hydrodynamic modeling needed for the tidal flow reduction, the dredging, see what impact that has.
Still not enough?
Then, if you still need more counterforce, you'd add the flush thrusters to FB6.
I see. So it's a tiered approach. Only spend what you need to spend at each stage.
Exactly. It demonstrates this really pragmatic, cost-effective way of tackling a complex problem. It really emphasizes the value of iterative solutions, adapting as you go, rather than just committing to one huge, expensive project up front.
That feels like a very sensible way to manage risk and the public purse. It's about smart, adaptive problem solving.
A principle that could apply to so many challenges, couldn't it? Urban planning, tech development.
Absolutely. It's also interesting just how many ideas don't make the final cut in these processes. Just quickly, why were some of those other initial ideas rejected after the detailed look?
Sure. Well, a pedestrian and cycle-only ferry, for instance, that was rejected because, well, it doesn't help vehicles at all.
Increases congestion elsewhere.
Right. Increases traffic on that Newport route. Plus, there were apparently legal complexities, too.
Okay. What about things like swinging bridges or transporter bridges, like the one in Newport, Wales?
Ruled out mainly on cost estimates were over 20 million, way above the threshold, and much longer timescales, over 10 years. Plus, big legal hurdles about interfering with navigation rights in the harbor and issues acquiring the necessary land.
Just too complex and expensive. And presumably the no crossing option was a definite non-starter.
Completely rejected, yes. Understandably.
And the impact of having no crossing at all.
Total loss of that direct connectivity, severely limiting economic growth for both towns, and significantly increasing congestion, pollution, carbon emissions from all that extra driving via Newport.
It really raises that important question, doesn't it? What's the true cost of doing nothing or choosing an inadequate solution?
Exactly. Sometimes the cost of inaction or the wrong action far outweighs the investment needed for a proper, sustainable fix.
So bringing this all together for you, our listener, why should you care about a ferry on the Isle of Wight? Because this deep dive, it just beautifully illustrates these really intricate challenges that communities everywhere face. Maintaining vital infrastructure.
It's a microcosm, really.
Yeah. Balancing history with future needs, finding solutions that are cost-effective, but also sustainable. It plays out in towns and cities all over the world.
Absolutely. It highlights just how important that thorough analysis is, and the need for sometimes creative, phased problem solving when you're dealing with public money and essential services.
It's a reminder that even these seemingly small local bits of infrastructure can have really complex, far-reaching impacts.
Definitely.
So where does this leave the Cowes Floating Bridge? The Isle of Wight Council is heading towards a decision scheduled for October 16th, 2025.
That's the timeline mentioned, yes.
And it seemed to boil down to two main proposed paths forward, beyond just sticking with the status quo. Path one, a brand new purpose-built vessel, FB7.
Yep, the clean slate approach.
Path two, a smart phased approach, modifying the existing FB6 and potentially its operational environment, starting with cheaper options first.
The adaptive value for money approach.
Both paths aiming to solve that critical chain clearance issue, get rid of the push boat and ensure that long-term connectivity, but obviously with very different price tags and different timelines.
Very different implications.
And this leaves us and you with a critical question to ponder, perhaps. When you're faced with these complex infrastructure problems, is the shiniest, newest, most technologically advanced, and often most expensive solution always the best one?
Or can a clever phased approach, one that builds on what you already have, maybe offers a more adaptable, more flexible, and crucially more fiscally responsible path forward? It kind of invites you to think about the trade-offs your own community might be facing or could face when it comes to keeping vital infrastructure working.